Okay, this is 13.1, the triangle sum theorem, which basically just says if you add all the angles of a triangle up, it adds to 180. You probably already know this. So I'm just going to kind of skip down to the bottom of it, and we're going to go into some details. So these two problems are both proofs, and they're wicked, and so buckle up. Here we go. So the first one, we always say given. Then we have that the measure of angle 1 plus the measure of angle 5 makes that angle right there. And that's just what it means to add angles. So you can say angle addition, definition of angle. Let me see. We are just adding definition of alternate interior community of linear pair, substitution property. I'll just say angle addition postulate because we're adding them. So ABE and 4, so that angle that we just had and 4 are a linear pair. Okay, that's just definition of a linear pair. And then we have they add up to 180, and that would be substitute. Let's see. So that would be really ridiculous. Stopping this again. Okay, so we start with given. Then that's the angle addition postulate. Okay, then it's the linear pair postulate. Where is that one? Linear pair postulate. And then we substitute it in. So we said that 1 and 5 make that. And those two add together. But then 1 and 5 is the ABE. So instead of ABE, we put 1 and 5 there. So there are two substitution property of equality things in here. So we're going to do that. Then we have that those are alternate interior angles. That's just the definition of them. And then this is what it means to be congruent. It's the alternate interior angles theorem because they're alternate interior angles. And then their measures are the same, would be just the definition of congruent angles. Then we have 1 plus 3 plus 2 is 180. And that is because of the substitution property. So there were two. This is the second substitution one. This one, I think. Is there another one? Because we had two of them, that one, and then that one. Did I already use that one? Maybe I'll use this one. They're the exact same thing. Yep, it's not. Okay, we're going to use the first substitution one on this one and the second substitution one on this one. Okay, and then the reason why we can do that is because right here, so we had 1, 5, and 4. So we already had 1. 3 was the same as 5. So instead of 5, we put 3. 2 is the same as 4. So instead of 4, we put 2. And then we just have to change the order, which is the commutative property of equality, of addition, I guess I should say. And then we get that. Whew. Okay. And then this one, we wanted to know, we have this triangle, we know it equals 180. There's 45, there's 90. So if we do 180 minus 90, we get 90. 90 minus 45 leaves us with 45. Okay. That was a long proof. Kind of nasty. Okay, next one, 13.2. I'm going to scroll down here so I can just do next. And then 13.2 coming up. 13.2, isosceles triangles. So with an isosceles triangle, we have these sides, and then we have these two that are opposite of those sides that are the same that are called the base angle. These angles are congruent. So those sides are the congruent, and the ones opposite of them, the angles opposite of them, are also congruent. They're the base angles, and they are congruent. And then other way around, if we know that those angles are congruent, then it's an isosceles triangle. Okay. And then if one angle in the triangle is a right angle, the other two angles are complementary, meaning they add up to 90, right? Okay, not going to do these proofs because I don't want to. And then we're going to go here. So use this figure to the thing. So we want to prove the thing. So for our triangle ABC, AC is congruent to AB. Which set of measures is possible for the measure of CAB? So let's see. CAB and CBA. So main thing we're looking for is that they are the same. Not the same, not the same, not the same, the same. Mark that one. Picture's horrible, but that's the one that's possible. Okay, next question. Proof. Always start with, don't even have to read it. Given. Okay, now I have to read it. So AB is congruent to CB, and BD bisects AB. So then 3 or 4 being congruent is definition of angle bisector. Then BD is congruent to itself. That's always, if something's congruent to itself, it's reflexive. So then we have a side, an angle, and a side. Let's make sure. So we have this side, angle, side. Yep. So they're congruent by side, angle, side. And then corresponding parts are congruent, CPCTC, and then that's just definition of congruence. Very good. Next one. Okay. A triangle has 2 congruent sides. Which answers list possible types of angles for this triangle? So it could be one obtuse angle and 2 angles with the same measure of 50. So let's just think. Obtuse means more than 90. So if we have 2 angles that measure 50 with the same measure of 50 degrees. So I made a mistake and I had to edit. So I'm going back. So we were actually on this one. One obtuse angle and 2 angles with the same measure of 50. So 50 plus 50 is 100. So 180 minus 100 leaves us with 80, which means that that cannot be obtuse because 80 is not obtuse. Then we have one obtuse angle and 2 angles with the same measure of 40 degrees. So 40 times 40 plus 40 is 80. And then that leaves the other one to be 100, which is obtuse. So that can be that one. If it's isosceles, we know that 2 of the angles have to be the same. So here they list 3 totally different angles. Can't be that one. It can be 1 right angle and 2 congruent two congruent acute angles. That would be 45 and 45. It could be it could not be 1 right angle and 2 acute angles with different measures. So submitting that one. And then the last part is the chapter 13 checkpoint, which I am going to do in a separate video.